In this video, we're completing example 2. We need to list the prime factors for each number below. Before we complete the example, we need to have a little discussion about what a prime number is. One definition is that prime numbers have only two factors. For example, let's take the number 5. The two factors for 5 are 5 and 1. Now, some people might argue that there are other factors. For example, we can make 5 by multiplying 2.5 by 2. This is not allowed, and the reason for that is you can't have a factor that's a decimal. So our factors need to be whole numbers. Some people might also argue that you can make 5 by multiplying -5 by -1. So we also need to mention that factors are not just whole numbers, they have to be positive whole numbers. Now there's actually a special name for positive whole numbers, and that's the set of natural numbers. So I think we should redefine what we've written here. So I've just written down that the factors must come from the set of natural numbers. Anyway, let's get into the example now. We're looking at question A, and we want to list the prime factors for 12. So what I suggest is finding any two factors that make 12. What numbers multiply to make 12? And the first two I can think of are 4 and 3. So I'm going to branch out from the 12, and I have the numbers 4 and 3, which are two factors for 12. Now I want to branch out again. Let's branch out from the 4. What two numbers multiply to make 4? And I can think of 2 times 2. Do I need to branch out from the 3? What would happen if I did that? Well, 3 times 1 makes 3. And that's quite useless because I can go on forever going 1 times 3, 1 times 3, and there's no point doing that. So when you're listing these factors, it can't be factors that are itself and 1. So basically, whenever you get to a prime number, you can't branch out any further. So I'm actually going to circle the 3 because I stopped there. My 2's are prime numbers as well, so I'm going to circle them, and I'm not going to branch out any further. I have now found my prime factors for 12, 2, 2, and 3. So I'm going to write them next to my 12. I'm going to say that 12 can be made from 2 times 2 times 3. These are my 3 prime factors. Now you should always check your answer. You should make sure that 2 times 2 times 3 is 12, which it is. And you should also use index notation when you come up with your solution. So I'm going to write it as 2 squared times 3. Now some of you might be wondering, is it possible to come up with a different list of prime factors? For example, if I started at 12 and branched out with 2 different factors this time, 6 and 2 makes 12. This is different to what I did before. I did 4 and 3. Now when I get to 6 and 2, I'm going to circle the 2 because it's prime, and then when I branch out from the 6, I get 2 and 3. And I'm going to circle these because these are prime numbers as well. Notice that I got the same list of prime factors. It doesn't matter how you branch out, you will always get the same list of prime factors here. Anyway, moving on to question B, we need to find the prime factors for 7. And 7 is a prime number in itself, so I can't branch out, otherwise I'll keep getting 7 times 1, 7 times 1. I guess in some way I should circle the 7 because that's where I'm going to stop. So all we can really say here is that 7 has only one prime factor, itself, which is 7. So we'll just write a little sentence here stating that. So we'll now move on to question C. We're going to branch out from 72, and we just need any two factors that multiply to make 72. And I'm thinking 9 times 8. Now I'm going to branch out from the 9. 3 times 3 makes 9, and both of these numbers are prime. Branching out from the 8, I get 4 times 2. 2 is prime, so I'm going to circle that. And branching out from the 4, I get 2 times 2. 2 and 2. So I've got 5 prime factors. If I was to list it in expanded form, it would be 2 times 2 times 2 times 3 times 3. But I would like to write it in index form. So next to my 72, I'm going to write that my prime factors are 2 to the power of 3 times 3 to the power of 2. Okay, now moving on to question D. I need to find 2 factors for 675. And I'm going to cheat a little bit. I'm going to grab the calculator because this is quite a large number. I can see it ends in a 5, so straight away I know that I can divide this by 5. I get 135. So my 2 factors I've come up with so far are 5 and 135. 5 is prime. So I'm going to branch out from 135. I know that 5 will be one of the factors because the number ends in a 5. So dividing this by 5, I get 27. So 5 times 27 makes 135. I need to circle my 5 here. Coming out from the 27, I know that 9 times 3 makes 27, circling my prime number 3. And then branching out from my 9, I get 3 times 3 to make 9. I've now listed all my primes here. I've got 3 3s and 2 5s. So I'm going to write here that my prime factors are 3 to the power of 3 times 5 to the power of 2. Anyway, that concludes example 2. Remember to read the description below for links to workbooklets that relate to this video.